Hi everyone, so this was a request from Giron Kessler, I hope I'm saying that right, to go over some of the hardest questions from the senior division of the 2018 AMC that was just done a couple months ago. So let's take a look at the questions. Alright, so the first question had these two circles inside a rectangle and touching the diagonal, and the rectangle is 5 by 12. And we want to find the distance between the two centers of the circles. So the distance from there to there. Now to do that we need to work out the radius of the circles. So that's where you sort of get stuck. How do we work out that radius? Well, what I did, I don't know if this is the most direct way to do it. Usually I have the solutions to work through, but of course the solutions haven't been released for this. But anyway, this is the way I did it. I sort of considered this triangle here, and then with these questions where you've got circles touching stuff, what you usually want to do is draw lines from the center of the circle to each of the points where it touches something. So like that, and we know that all of those distances are the same. They're both, I mean, they're all the radius are. And my idea was to use similar triangles with, you've got this triangle here and this triangle here and the big one, they're all similar. So what we might do first is work out that side length, just using Pythagoras. So it's going to be 13, so the 5 squared plus the 12 squared, and then take the square root. And that will give us the ratios of the sides in that triangle and that triangle. So actually first let's work out that distance. If that's r, then that's the same, that's also r. So this bit is 12 minus r. And then because the ratio of that side to that side is the same as that one to that one, that means this whole distance here is 5 times that one over 12. And then we can do a similar thing in this triangle, and so that's ratio of that side to that side is the same as that one to that one, because of that triangle being similar to this one. And that will give you that this is 13r over 12, so just that bit. And then from that, you've got that height in two different ways. You can call it that, or you can call it that plus that. So we can say 5 times 12 minus r over 12 is that plus that. And then we can just solve that equation for r. So let's multiply both sides by 12. So that'll get rid of the denominator there, and let's expand that. So that's 60 minus 5r and 12r plus 13r, so that's 25r. And then move that across, so we've got 60 equals 30r and r equals 2. And then from there we can work out this distance by making a little right angle triangle there, where that distance is the 12 minus 2 there, since we know the radius is 2 now, minus that 2 and minus that 2. So that makes 8, is that side. And then this one is the 5 minus 2 and minus that 2, so that's 1. So then we can just use Pythagoras here, so we've got that squared plus that squared is 64 plus 1, which is 65, so this is root 65 is the answer to that one. In this question, A is a number with 2018 digits and it's divisible by 9. B is the sum of A's digits, C is the sum of B's digits, and the question is what is the sum of all possible values of C? So we've got to work out what C can be and then add up all those possible values. Someone asked me about this before, but they didn't remember the exact wording of it, about it, that it was asking for the sum of all the possible values, so I couldn't answer that at the time. But now that I have the exact question, we can go over that. All right, so let's think about things that B could be. If you've got a number that's divisible by 9, then the sum of its digits is always a multiple of 9. So we are expecting that some of A's digits could be something like 9, 18, etc. I mean, we've got to make sure all those things are possible. So let's actually think, can we have a 2018 digit number whose sum of the digits is 9? Yeah, you can. You can have a 9 followed by 2017 zeros, so that works. And then same sort of thing for these. You can have 3 9s followed by however many zeros, and so on up to 2018 times 9 would be the highest value that B could have, because that would just be, 2018 nines is what A would be. And we obviously can't go higher than that. So all of those would be possible values for B. So now let's think about what C can be. So C also has to be a multiple of 9 because all of these are multiples of 9. You can see like that one adds up to 9, that one adds up to 9, and so on. So obviously 9 is a possible value for C. And then we got to think, can we have 18 and 27 and so on? So C could be 18 if B was 99, for instance, because then C would be 9 plus 9. And 99 is a possible value because that's just 11 times 9, so that's definitely in that sequence. So we could have 18. To get 27 for C, you'd have to have 999, which also is possible. That's in that range, because that's 111 times 9, so that's fine. So 27 is possible. Let's think about 36. So that would require something like 9999, which is 1111 times 9. So that's okay, that's still within that range. So we can get 36. But to get 45, you'd need like 5 9s, and that's that number times 9, which isn't in the range. I don't think there's any way that you could get 5 9s. Like, I don't think there's any way you can get 45 for C. So it's just those 4 possibilities. And then we just need to add those up because it was asking for the sum. So 9 plus 18 plus 27 plus 36, which equals 90, I think. So that's the answer to that one. In this question, we have a trapezium that's been cut into these 4 quadrilaterals. This point is connected to the midpoint of each side. So like that equals that length, and that equals that, and so on. And all of these quadrilaterals have equal area. And we're asked to find the distance from there to there. Okay, so the first thing I did with this is, because we want to work out that distance, what we need to do is work out that length and that length. So let's actually just cut up this whole thing into sections like that. So if we can work out that and that, then that'll give us that length. Now let's see how we can use this fact about the equal areas. So, we need some way to like say what the area of this is. So what I would do is cut it along there, and now it's in 2 triangles. We can work out the area of those triangles. So one thing you might notice is, okay, so we can work out, like, since that's the midpoint of this side, we know that that's 60 and that's 60, that's 50 and that's 50, that's 65 and 65, and so on. And then what we can do is this height here, we don't know what it is yet, but we know that the area of this triangle is half of the 60 times that height. But so is the area of this triangle, because they actually have that same height. So the area of this triangle has to equal the area of that one, because they have the same base and height. And then if this area equals this area, and this bit equals that bit, that means the area of that triangle has to equal the area of that triangle. That's really useful. So now we can write an equation with that. let's call this y and that x, and then this will be that length minus y, so that's 120 minus y. So then we can say, so the base of that triangle times its height is equal to the base of this triangle times its height, because we know that those two areas are equal. So 50 times y. Okay, well, we can now solve that for y. So what I would do first to make this easier is divide both sides by 25 so that we can simplify that. Otherwise, we're going to have to do that multiplication, which I don't really want to do. So that will give us 120 minus y equals 2y, and then we can expand this. So we get 5y is 360, y is 72. Okay, that's really useful. Now to work this one out is a bit harder because this side isn't square. So we need a way to work out, yeah, this bit's tricky. So what I did here, like, we also need to think about the height of these two triangles. So I would also draw a perpendicular going there. So like this one's parallel with that side, but we also need to think about that one. I'm going to call that Z, and let's call that W. And then, yeah, this one's quite complicated. I don't know if there's an easier way to do this. Like I said, I don't have the solutions yet, so I don't know if this is the best method. So what I said was like the same sort of trick. Like, we know that this triangle has the same area as this triangle because they have the same base and height. And then because these two quadrilaterals have the same area, that means that that triangle has to have the same area as that triangle. So we can say like 60 times x, so that triangle's base times its height, is equal to this triangle's base times its height. So 65 times the z is the height, not the w. Remember, you have to do heights perpendicular to the base. So let's simplify that. Then we can just divide both sides by 5. So that'll give us 12x is 13z. Alright, well that's a good start. Now let's see what we can do with w. See if we can work something out about this. So what I would notice with this is that this triangle is similar to this one if I cut that off along there. That triangle is similar to that one because we've got the right angle and we've got that angle is the same as that one because those lines are parallel. So I'm just going to redraw this one down here. Let's work out the sides. So we know that one's 130. This side is the 120, and this one is this, which is the 150 minus the 100, so that's 50. So we know that that triangle has those same ratios, so we could say something like Z on W is, that's corresponding to that side, it's 120 on, and that's the hypotenuse, so that's that one. And we can cancel that. So we've got, we can solve that for W. You get W is 13 on 12Z. And then this one, if you solve that for X, you'd actually get X is 13 on 12Z as well. So that means X has to equal W. I don't know if there's an easier way to get to that. It seems like something that maybe there is an easier way, but I don't know. Okay, well that's good. That means that if we can work out that distance, then we can work out X. So let's think about what that distance is going to be. So what I would do there is consider, I know this diagram is getting super complicated with all these lines, But let's consider this triangle here. Because, okay, if we want to work out that total length, we know that the length from there to there is 100 because it's the same as that. So if I can work out that distance, then we're good. And this triangle is similar to this one again. And we know the height of that one because that's y, which we worked out before. That's 72. So that'll give us that one will be 72 times the 50 on 120. Okay, so sorry, this is that distance there. So 72 times that ratio. And so that's that distance. If we add 100 to that, that'll give us that total length. So let's simplify this. We can cancel those. 72 divided by 12 is 6. So we've got 6 times 5 is 30, so this is 130. And that's x plus w. Okay, I don't know if there's a simpler way to do that. That seemed really complicated, but it is one of the final questions, so it is going to be hard. And then we know that x is w, so this is 2x. So x equals 65. And now we've got all the information we need because we've got that's 65 and that's 72. So that's going to be the square root of 65 squared plus 72 squared. So we just have to work that out. I don't think you're allowed a calculator on this one, so let's do that. 5 times 5 is 25, 2, and then 30, 36, 9. I should have left more space there. So that's 2. Okay, so 65 squared is that, and then 72 squared. 9, 4, 8, 2, 5, and then we just need to add those. Nine. Okay, and then we need to work out the square root of that, which isn't as hard as it looks. You might know like the procedure for working that out, or if you don't, you can just sort of estimate, like, okay, it's we know that 100 squared is 10,000, so the square root of that is going to be a bit less than 100, and we know that 90 squared is 8100, so it's the square root of that's going to be somewhere between 90 and 100, and we just need to think like what would give us a 9 at the end, because the last digit only depends on the last digit of the square root. So it could be something like 93 because 3 squared is 9, or it could be 97 because 7 squared is 49, so that would give us the 9 there. So we could test these out, and then you'll see that 97 squared, ignore that, that's 9, 4, 63, and then and then that makes what have I done? I'm sure it works out. I tried this out before. Anyway, so it does work. I did test this out before. I've just made a small mistake somewhere, I suspect. So the answer is 97 for this one. Alright, I see what I've done. That should have been a 0. And then that's just 4 there. All good. In this question we have n overlapping circles. This is just the diagram for n equals 7. And they all pass through this point, and they're all sort of evenly spaced so that we have rotational symmetry. Each circle has a circumference of 1, and we're told that the total arc length is 60, so the sum of all of these lines line lengths is 60, and we've got to work out what n is. So this is just the diagram for n equals 7. This isn't like the one that would have an arc length of 60. So, what I did first with this one is consider, like, draw these lines in, and then we know that this is a seventh of, well, an nth of the whole 360 degrees. So I'm just going to call that 1 over n, and actually let's draw in the rest of this circle. That was not really where it was. There we go. Okay. Now you might know, I mean, what I really mean by that is an nth of 360, but I'm just going to write it as 1 over n. Now you might know that that the angle at the center of a circle is twice the angle at the circumference. So that means that has to be 2 over n. If you didn't know that, it's not that hard to work out. You would just go, not that, you would just go, like, we know this angle, let's call that alpha and that beta. That's the same as that because they're both radii, so this is isosceles, that means that has to be alpha, similarly that has to be beta. Then this one is 180 minus 2 beta because of angle sum in there, and that one's 180 minus 2 alpha. And then this one is 360 minus both of those, so that simplifies to 2 alpha plus beta. And then alpha plus beta was this angle, so this one has to be twice that one. So it is possible to do it. If you didn't know that fact, you would just have to derive it. But anyway, that gives us that that angle is twice as much as that one, so 2 over n. And then that arc length is 2 over n. Because it's, I mean, what I mean there is like 2 over n of 360, and then we know the whole circumference is 1, so this is going to be 2 over n of 1. And then we're going to work out this bit as well. So that angle there, you can imagine like the whole thing is 360, and then you want to minus that much of 360, gives you that angle, and then half of that. So that was a confusing way to explain it, but this is going to be that angle there is going to be 1 minus the 2 on n divided by 2, like that much of 360, because you've got, so the 1 minus 2 on n is that whole angle, and then you halve that because that's the same as that. So that will give you that arc length. And that simplifies to 1 over 2 minus 1 over n. So we know that one and we know that one. And then, so we can just put those together. That makes half plus 1 on n. So that is that entire thing. And then you've got n of the circles. So just n times that. And we know that that equals 60. So that'll give us n on 2 plus 1 equals 60, or n over 2 is 59, and n is 118. All right, last question. So we have an n by n grid of numbers ranging from 1 up to 16, up to n squared. I've just drawn it up for n equals 4. In the question, they did it for n equals 3, but the first thing I did to try to figure it out was to draw it up for n equals 4, so I thought I'd write that out. And they're talking about shuffling the grid, which involves shifting everything right and then down. So you can see, for example, the 6 has shifted right and then down, and it ends up there. But the thing is that when a number's on the end and you shift it right, it ends up at the start of the next row. So the 8 moves from there to there, and then shifts down to there. And when you do the shift down, if you're on the bottom, you instead of just wrapping back up to there, you end up at the start of the next column. So the 13 goes up to there. And the one on the bottom right ends up at the top left when you shift down, and also when you shift right, bottom right ends up at the top left. So the question is, if it takes at least 20,000 shuffles to return to the original configuration, so this is one shuffle, just shifting right and down is one shuffle, not two shuffles. What's the minimum value of n, which needs more than 20,000 shuffles? Okay, so what I would do first to try to figure this out is have a look at how numbers move. So like how many shuffles it takes to get back to the original position. So we could look at the number in there. First shuffle, it goes right and down, goes there, and then there, and then there. And then when it shifts right, remember it ends up here and then goes down. Like the 16 did, it went there and then down. So that ends up there. And then it goes there, and then there. And then it goes right and then down and wraps around to here. So it ends up back there in 1, 2, 3, 4, 5, 6, 7 jumps. And all of those numbers will have 7 jumps to get back to the original because they all go through the same cycle. So all of those take 7 shuffles to get back to the original position. Let's look at other numbers. So for example, this one will move to there, and then to there, and then it goes right, and then down, ends up back here again. So that one just takes 3 jumps. We could look at that one goes 1 shuffle, 2 shuffles, and then it goes back to its original position. So that one's also 3. And then you'd probably expect that this one, and mark that for plus, that goes right down to here. Yeah, goes right, ends up there, and then goes down, and then goes there, and then ends up there again. So that's also 3. So for n equals 4, if these numbers take 7 shuffles to get back to the original position, and these numbers all take 3 shuffles, then the minimum number of shuffles to get back to the original position is 21. So 7 times 3. Okay, so that's interesting. Now let's try it for n equals 5 as well. So I didn't prepare an n equals 5 grid. Let me just add some onto here. So we can do the same thing. This one goes there, and then there, and then there, and then there, and then again ends up here. It keeps going around, and then you'll find that it goes back to there. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9 shuffles to get back to the original position. And we probably want to start thinking about a formula for that. So this is for n equals 5. So there's 5 along there, so n little squares along there, and then there's n minus 1 there. So that's probably going to be n plus n minus 1. So that worked also for n equals 4 to get the 7, because that was 4 plus 3. So that's probably going to be like our formula for the number of shuffles to do that. Alright, and then let's have a look at this one. That goes there, and then there, and then there, and then it goes right, and then down, ends up here again. So that's just 4 shuffles. Let's call that n minus 1, because you'll notice for this one it was n minus 1 as well. This one to get back to its original position. And then if you do any of these other squares as well, you find that they end up back to their original position in also n minus 1 shuffles. So you can do it for that and that one as well, and that one. They'll all be n minus 1. So that looks like a pretty reliable pattern, and yeah, you can kind of see that that's going to work for any value of n, that the ones on the diagonal are going to go there first and then end up back in the original position, and anything that's off this area is just going to go like on a diagonal and then end up back where it started. So what the number of shuffles is to return to the original configuration is going to be, well, really what we want is the lowest common multiple of the 2n minus 1 and the n minus 1. So that might be just plain multiplying them if there's no common factors, or it might be a bit more complicated. Hopefully that makes sense to you, that, I mean, the number of shuffles needs to be a multiple of both that one and that one. So the minimum number of shuffles to return to the original configuration has to be the lowest common multiple of these two numbers. So we want that to be at least 20,000. So we might guess that the LCM of these two is going to be 2n minus 1 times n minus 1, and that we want that to be roughly 20,000. So, you know what, since we're just talking about roughly, let's just say this is approximately 2n times n. So 2n squared is about 20,000. So that makes n around 100. And then, so we could try n equals 100 and see what happens. So you're going to get 2 times 100 minus 1 is 199, and 100 minus 1 is 99. Now that's going to be less than 20,000, so n equals 100 isn't going to work, but we could try n equals 101. So 2 times 101 is 202, minus the 1 is 201, and then you've got the 101 minus 1 is 100. Now we have to check for common factors, because that's going to mess with the LCM, like it's not going to equal that if there's any common factors between these two. But the only prime factors of 100 are 2 and 5, and neither of those divides 201. So we're good with that, like that's going to be the LCM of those two numbers. And that's equal to 20,100. So that should be the first number of shuffles that's over 20,000, and that happened for n equals 101. So I think that's the answer. Again, I have been known to make mistakes with these on occasion, and I don't have the solutions yet. I assume they'll come out sometime before next year. And I'll put a link in the description for where you would be able to buy those once they do come out. They're not out now. But I think the answer to that one is 101. Alright, that's it for today. Now, let me know in the comments if there was anything that you're still confused about, because I was trying to go through those questions quite quickly, because I think this video is really long already. So there may be a few things that were really confusing and not well explained. So do let me know if there's anything that still confuses you. And I hope I didn't get any of them wrong. We'll see.